Hello everyone, this is Dustin again. Today we're on part 2 of our tutorial, sending transactions on the Nebulas blockchain. And for this tutorial, we're going to learn how to do 3 different methods of sending transactions. We're going to do a sign and send, a send with password, and an unlock and send. And so we're going to go through each step of these, and yeah, by the end of this, you should have a pretty good understanding of how to actually send funds in the blockchain. It's also going to go a little deeper into confirming transactions and also seeing the balances of each address. So let's begin. First thing we need to do is open up our browser so we can follow the guide. So github.com/nebulasio under the wiki, tutorials, and number 2. Okay. And so we're going to come down to here, the recipient, and we're going to create a new wallet. So I'm going to make a new terminal window. And I am also going to make a new text document because we're going to have some notes to keep track of as we go along with this step. And we're just going to keep the background terminals running. So first thing we got to do is create a new account. So .neb, whoops. So first thing we got to do is create a new account. First, make sure that you are in your Go Nebulas directory where we built the neb binary. Depending on the path that you decided, it could be a different location as mine. Just keep track of that. And so I'm just going to execute this command, neb account new, and we have to set a password for here. So I'm just going to set a simple password. You should make yours pretty strong and keep it somewhere safe. And here we are. This is the address that we've received in return. So this is our newly set up account. And so we're going to verify that the account exists via looking at the key store directory. And we're going to see we have a file with that address name in it. So cd key store, or key directory. No, what is it? Keydir. Okay. Oh, I had an extra S in there. There we go. Do a directory listing, and let's see, N1Z FB. There we are. See, we have this new file here. If you wanted to, we can look at it. Don't edit it. And same as the previous example. It has the same data in it, the address, cipher used, and all that fun stuff. So nothing we have to worry about at this time. So make sure you keep track of your address. And now this talks about starting the nodes. We already have our nodes running, so I'm not going to worry about that. But if you do not have nodes running, you need to get some nodes going. So here we have just our standard node as well as the miner node. And in the previous example, we verified the configuration file config example miner was using this address here for block minting. We're going to check in a moment and see exactly how many NAS tokens we have in this address. And so now interacting with nodes. Nebulas uses 2 API modules. It uses a non-permission based API system as well as permission based. And let's take a quick look at what those look like. And so non-permission based ones will use user in the address you're sending it to, whereas if we look at the permission based, they will always use admin. Let's see admin right there. The RPC documentation is very important to look at. It can tell you everything you can do with the blockchain, how you communicate with it, as well as what type of request is needed. Is it a GET request or is it a POST request? And so depending on what type of request you need to submit, the request will be approved or not. And so right now we are looking at the RPC admin documentation, and if we scroll this over here now, we see admin, and let's say for example we're sending a new account, we would have to enter a passphrase, And so you need to, this would actually just generate a new address and then it would give us a result. And for like this example, let's say you want to unlock an address. So you have to specify what address you want to unlock and then also include the passphrase. So if we look at the other methods for RPCs, we can notice that they will not ask for passphrases at any point because these are all things that, this is basically everything that is public information on the blockchain that you can use to validate transactions and see how many funds are in specific addresses and anything like that. So very important to look at. All right, so here's our first request. We're going to check the account state. I'm going to copy this out so we can take a better look at it. And so we have a simple curl request. And so these are all different types of options for curl. So the I option is to include an HTML response when you submit data. And H is for the headers. We can say specifically what type of data we are submitting. So this time we are doing application/JSON data. And I should also mention that everything that you submit or receive from .neb will be in the JSON data format. So we can see that everything that we execute is a simple JSON string. Next is the X option, and this is when we set the data type. Is it a post or is it a get? And most of the time we're going to be using post, especially in this tutorial. There are times where we will be using the get, but not today. And so if we look here, what version are we running? We're running version 1 of Nebulas. The user, this will either be user or admin. That depends on if it's a standard RPC request or RPC admin request. If it's an RPC admin request, this will say admin. Then finally, what exactly we want to check. And in this time, we want to check the account state. D is the data that we are submitting. And again, that's just a simple JSON data string that we are sending. And notice how it has single quotes on the outside and then double quotes for the actual data on the inside. And if you need to send a single quoted piece of information, you can escape the string. So I'm going to copy that. And the address here is the address of our miner that we set in the previous tutorial. Now we execute it. Oh, we get a little error here. The program curl is not installed. That's because, again, we are running a clean version of Ubuntu, and so we need to install some packages. Great. Let's execute this command again. All right, and there we have it. We have a balance, the nonce level, how many transactions has taken place on this address. And the nonce is very important. So like, let's say you're trying to send multiple transactions at once. You cannot use the same nonce. It has to be a different height each time. And the reason for that is to stop any double play attacks on the network. A double play is basically trying to do multiple transactions at once. And notice how the string return is just a simple data string, simple JSON data string. And now, if we check the address that we created here, so you can see here your address. We're just going to copy our address into this string, paste it in, and we have a balance of 0 and a nonce of 0. No transactions have taken place on this, and this address has not received any funds yet, but that's about to change. Okay, so now we're going to talk about the 3 separate ways of sending transactions using the Nebulas API service. So first is sign and send. We're going to copy this, and we're going to break it down. So same as before, simple curl request, same options as before, same data format, posting data. And if you look this time, we can see we are working as with the admin RPC request, not a user state. And so what we want to do is sign a transaction, the data that we are submitting. And so depending on what exactly you're doing with the admin RPC or any of the either of the RPCs, it's going to have different types of data. And so in this case, we need to have transaction, the from address. This from address needs to be an address on your local node, so you can have the private key available to sign the transaction. The to address, where we're sending funds to, and we're actually going to switch this out to the address that we made earlier on, and also the address that we just checked how much funds are, which are 0. How much you want to send to the address, the announce level. And so we see here our announce level is currently 4 with the mining address. And so we're going to set this announce level to 5. How much we're willing to pay for the transaction, that's the gas price, or how much we want to pay and what the limit of the gas is. And then finally, what the passphrase of our specific address is. In this case, the passphrase is simply passphrase. So we're going to copy that, paste that in, and what we get back, well, let's copy this out. We have a result. And so our result is a simple data string, this nice long data string. This is a signed request. And so this information was generated using the from address private key and also the to address. And this is the result. This is basically confirming that we have permission to do the transaction. And so our next step is to actually submit that raw transaction. Let's copy this. And if we look at our RPC request, we're actually using a user type of RPC, not an admin type. And we are doing a raw transaction. And here's all our data. And so what we're going to do is actually copy our entire data string that we received from the previous request we submitted. And we're going to paste this in the data of our new request. So if we look at it now, we have everything here. We're doing a user RPC request, raw transaction, and the data that we obtained from the previous transaction or from the previously ran command. And if we execute this, we can see we have a result that includes a transaction hash and a contract address. Let's copy this out. And so transaction hash is very important. That is how we can confirm the transaction is confirmed. And we're going to look closer at that further on. There's also another field called contract address. So let's say, for example, we are deploying a smart contract to Nebulas. That we would have a transaction hash as well as a contract address. And that contract address is unique and is used specifically to call that specific contract. So obviously this time we just did a simple send funds transaction, so no contract address was generated for us. And that pretty much does it to send funds using sign and send. All right, and so now we're going to send another transaction using transaction with passphrase request on the API. And notice how this is an admin request, and so we need to have a passphrase. There it is. And so it's very similar as the previous one. Instead of signing, though, it's going to sign and send the transaction in one step. And so let's make sure we have our correct address in there. Paste this in. Oh, and so we get a transaction announce error. So our announce actually needs to be 6. So if we run this, if you ever get that error, you could do an account state to verify the announce height. And oh, yep, we see we have announce height of 5, so this needs to be 6. So if we execute this again, there we go. We get a transaction hash. And of course, no contract address because we did not submit a contract to the chain. All right. And next one is unlock and send. And now this is a more dangerous method. The reason for this is, let's say you're not in a fully secure, or someone else may have permission to the same server as you for whatever reason. You are literally unlocking your wallet, making it available for any other user on that server to basically interact with your wallet. And so you could keep it unlocked and you could lose all your funds. And so you have to be real careful with this. So with that said, I am going to show you how to unlock and send transactions. And so it's a two-step transaction. First, of course, let's look at our command again. It's an admin request, and we're talking to the account, and we are doing an unlock request. And of course, we have to set the address we're unlocking. This is the address that we have been using, which is the minor address. You have to set the passphrase of the address and how long we are going to unlock the wallet for, how long we're going to make it available without the need of using a password to interact with. And so in this example, it's 300 seconds, so 5 minutes of time. And let's execute this. And our result is true. So like, let's say for example, if the password was wrong and we executed it, we get an error, could not decipher. Okay. So let's run this again just to make sure that it's still unlocked before moving to the next step and get a true result. Excellent. And now we are going to send it. And so now when we look at the request, it's an admin request again, and we want to do a transaction. But notice this time in our admin request, there is no need for a password. That is due to the fact that we have unlocked the wallet in the previous step for 5 minutes. And so you have to make sure you do complete what you need to do within that time frame. And so we're just going to check this again. The from address is our mining address, and the to address is what we created earlier. Let's copy that, paste it in. Oh, and transaction nonce is invalid. So let's set our transaction nonce to the proper height. I believe it should be 7 this time. And there we go. We get a successful transaction hash. Now, I'm going to show you what happens if, let's set the duration down to 300 milliseconds instead of 5 minutes. Oops, do not need that open. So let's execute this command. Same thing as before, we get a true result. And so now let's try to run this command again, up the nonce level. Execute it, and we get account is locked. That's because we did not succeed in sending our transaction or communicating with the wallet within that 300 millisecond timeline. And now let's look at transaction receipts, confirming that transactions are in the blockchain and are successful. So it's a user request. It does not require permission. Get transaction receipt, and we need the hash of a transaction. And so we're going to find the hash of our previously set transaction. There it is. Copy that. Going to paste it in. And we're going to submit this. And here is the result of our request. All right. So of course the normal stuff, the hash that we just submitted, same thing. The chain ID that we're working on, we set that earlier in the admin area, and that is the chain that our nodes are communicating with, the from address, the to address, the value of the transaction, how much of the funds were sent, the nonce level, timestamp in Unix epoch time, the type of data set, binary, The data, null. This will can be other than null when you are communicating with a smart contract. And so when you're sending data to a smart contract, this is where the data will be. How much was the gas price, the gas limit of the transaction, what the contract address was when creating a contract. Again, we didn't do that, so that contract address is empty. Status, we get a 2 this time. The reason for that is that the transaction is still pending. It hasn't been put into the blockchain yet. So if we wait here for our miner to mine a block, it will be included in the next one. And then finally, we have gas used. How much gas did we actually use in the transaction? Any errors with the process, and finally any results with the process. And so let's see, I'm not sure if we got a new block yet, but let's check. And we still got a status of 2, so let's just wait a moment for a block to be minted. All right, so we just had a successfully mined block. So if we run the same command again, we have a status of 1, and also we have how much gas we used. And that's it. Okay. Next, final thing is to check and see what our account state is of the address we've been communicating with. And so here we used the account state earlier. Let's get rid of all this. And so we're going to put in the account state the address that we made in the beginning of the tutorial. Paste this in. And here we are. Here's our balance, what our nonce level would be. And that concludes this tutorial. Next step is tutorial 3, and we are actually going to write and execute a smart contract using JavaScript. Should be fun. Bye.